Hello students, welcome back to one more exciting session of physical chemistry. My name is Lalit Chauhan and I'll be teaching you physical chemistry as of now. And we are doing balancing of redox reaction. We have already covered up the basics of oxidation and reduction. We have done some questions to cement all those concepts as well. And I believe that one should be practicing some unsolved questions apart from what you are doing in the class. Practicing unknown questions is very, very much important because it will test your caliber, that how you will handle those unknown questions in the examination hall. So your gravity will increase, your potential to handle the unknown and the pressure game will also increase. So keep on practicing some good questions as usual and do hell lot of practice. So today we'll be doing the balancing of redox reaction actually. And it's a very important topic and I have been getting a lot of demands. That's why please do record a lecture on redox reaction. So I'm doing it right now. So there are two sections of balancing of redox reaction. One will be balancing the redox reaction in the acidic medium. Other will be balancing the redox reaction in the basic medium. First we will learn how to balance the reactions in the acidic medium. Because balancing in the basic medium is comparatively very easy. It's just one more step. What is that step? I'll just let you know once we do balancing in the acidic medium. So before I begin, one last thing. I'll be teaching you 4 or 5 basic equations and it will be your homework that you are learning all those 4 or 5 basic equations. You can opt out that, sir, okay, we'll take care of it in the examination hall. Don't do the same mistake which your seniors have done and it has resulted in their failure. See, whatever the teacher is saying, just keep on doing that stuff religiously. You will not go into any kind of trouble, that I can assure you. So I'll be doing 4 or 5 basic equations. Learn those equations because once you learn those equations, everything will fall in place and you will be able to handle the redox questions in a blink of an eye. So it's so important. So let me begin that stuff. So I'll be teaching you how to balance the redox reaction in acidic medium. I'll begin with that. So whenever an equation is given, like say some element X is there. So first of all, try to balance that X element on both the sides. Second step will be that you will be balancing the oxygen atom by adding water molecules, okay? You will be adding water molecules where oxygen is in deficiency. I'll let you know, don't worry, just listen now. And then once the element apart from oxygen and hydrogen are balanced, you will proceed to balance oxygen and then balance hydrogen by adding H ions in the acidic medium. Which side you will add H ions? Where the H are in deficiency. And finally, you will balance charge by adding electrons. Only addition of electron is permitted in these reactions, chemical reactions, okay? And there is a reason for that, because any chemical reaction involves transfer of electrons. So you can simply add electrons. Which side you will add electrons? You will add electrons to that side where we have got excess. We have got excess of positive charge. Remember that? So what I have told you, 4 steps will be followed in all the questions. First of all, balance the element apart from oxygen and hydrogen. Once it is balanced, then balance oxygen by adding water molecules. Where you will add water molecules? Where the oxygen, the side where the oxygen is in deficiency. Next, you will balance H atoms by adding what? H ions. Where you will add H ions? Where hydrogen atoms are in deficiency. And then finally, we'll add electrons to balance the charge. Now, which side you will add electrons? Where we have got excess of positive charge, always. Okay, so loaded with this guide, we can launch on to questions. We'll begin it. And the first question I'm going to do is extremely important. Let me tell you, MnO4 negative, permanganate, Cr2O72 negative, dichromate. These 2 oxidizing agents are the most important oxidizing agent in 11th and 12th class chemistry. Apart from that, we will do oxalate ion and H2O2 also. These 2 ions are also very important component of 11th and 12th class chemistry syllabus as far as NEET and IIT are concerned. Okay, so we'll be doing those. Let's begin the journey. So we have got MnO4 negative, this they will give you, and we have Mn2 plus this side. Remember that we are going to balance these equations first in what? Acidic medium. So MnO4 negative will convert into Mn2 plus. Now we have to balance it. So what I told you that first of all we'll balance all the atoms except oxygen and hydrogen. So Mn is balanced, yes, 1 and 1 there, nothing to be done. Then we'll balance oxygen. So we have got 4 oxygen atoms this side. So we will be adding 4 water molecules to balance oxygen. 4O that side also, yes or no? Now we'll balance hydrogen atoms. We have got 4 into 2, 8 H atoms. To balance 8 H atoms, I'll be adding 8 H ions where the H atoms are in deficiency. This side is in deficiency. Now Mn balanced, oxygen also balanced, and H atoms are also balanced. Now one thing is left. What is that? Charge. Now see the charge. We have got -1 on this. We have got 1 H plus. 1 H plus has got 1 plus. 8 will have +8. So net charge is now +7. Okay, now this side we have got only water is neutral. We have got Mn 2 plus, only +2 charge is there. Now +7 is more than +2. So excess of positive charge is this side. I told you to add electrons where the excess of positive charge is there. Excess of positive charge is more here. And how many electrons I should add? I should add 5 electrons because each electron contains -1. 5 will contain -5. So +7 -5 will be equal to what? +2. So both the sides will get balanced now by adding what? 5 electrons. Are you getting that? So I will be adding 5 electrons this side. Now my equation is completely balanced. Yes or no? So the kind of question they will ask you will be they will give you imbalanced equations. For example, they can give you MnO4 negative plus AH plus B E negative electron and Mn2 plus and maybe CH2O. So in these kind of questions they can ask you what are the values of the stoichiometric coefficient of H plus, electron and water. So out here A will be 8, B will be 5 and 4 will be C value. Yes or no? So these kind of questions they can ask you. And this is what? This is a reduction reaction because in this question MnO4 negative is accepting 5 electrons. So this is a reduction reaction and MnO4 negative becomes an oxidizing agent. An agent which will accept electron and will get reduced is called an oxidizing agent. Yes or no? Clear? So you have to learn this equation. Learn it. है ना? चलो, we'll learn together. So come on. MnO4 negative. MnO4 negative, 8H plus, 5 electrons giving you Mn2 plus and 4H2O. I hope you are writing in the copy as well. Practice, do practice, hell lot of practice because these are the only equations in your syllabus. Once you command them, learn them, then in the examination you will not feel any kind of pressure and your accuracy rate will also go up. Okay, so keep on practicing, keep on learning rather than, and I'm not saying that learn 50 60 equations. I'm saying just learn 4 or 5 basic equations. That's so you can do any given day. You're already learning so much of biology, so much other part of the chemistry and physics. Why can't we learn 4 equations as well? We can, and you will, you have to. Okay, the next question contains a very important oxidizing agent and that is dichromate ion Cr2O7 2-, and this will be giving you Cr3 plus. This information they will provide you. Now they will ask you to balance this equation. Okay, so again where? In the acidic medium. So we'll follow the same standard procedure. First balance all the atoms except oxygen and hydrogen. So chromium is there. So chromium is 2 here. It is 1. Can I multiply by 2? Yes, I can multiply by 2. Now oxygen 7. So I will add 7 H2O to the side where oxygen is in deficiency. Yes or no? Okay, I have added that stuff. Now oxygen balanced. So now we have got 14 H atoms. 14 H atoms. To balance them, I'll add 14 H plus this side. Yes or no? Now chromium balanced, oxygen balanced and H atoms also balanced. Now it's turn of charge now. So let's say -2 on dichromate ion and each hydrogen has got 1 positive, 14 will have 14. So total becomes +12. Yes or no? Okay, now come to the RHS, right hand side. 1 chromium has got 3 plus. So 2 chromium will have 3 plus 3, 6 plus. Yes or no? Or +6 charge. We'll have +6 6 charge. How can I convert plus 12 into plus 6? By adding electrons to the excess positive charge. So I believe I should add 6 electrons. Yes or no? 12 minus 6 will be plus 6. So I can add 6 electrons on this side. So this equation is now completely balanced. Every atom and charge is also balanced. So you have to learn this equation also. This is that these two equations I've done, MnO4 negative and dichromate, they are very, very important part of physical chemistry, redox reactions. So do learn them. So we learn it. So dichromate, Cr2O7, 2 minus plus 14H plus and 6 electrons giving you 2 Cr3 plus and obviously 7H2O. So learn it. Yes, you can balance it in the examination hall also, but it will consume some time and you will be running short of time in the examination hall. So why don't you learn it? And it is also a possibility that you can commit some blunder also there. So you will be escaping that blunder part also if you learn these things. There's a big difference between toppers and the average students. Average students, they don't do the homework and they don't do it religiously. Topper will do it religiously. His efforts will be on different level. So they are very obedient from the point of view that the teacher says and they deliver. They just do it. They say, so tell me how I'll score 700 plus. So teacher says, for example, do this and do this as well. So I'll do it. Tell me one more thing, what I can do. An average person, an average student, he tries to escape. He procrastinates the things. He like shifts the focus on tomorrow kind of thing. I'll do it tomorrow, I'll do it later on. And that procrastination is the difference between the topper and the average students. So any average student, if he want to become a topper, he should delete the word called procrastination from the dictionary. Okay, believe in the moment, believe in your teacher, trust them and keep on doing a proper homework. Okay, and don't compromise with two things. If something has to be understood, understand it. Don't try to mug it up. And if something has to be learned, learn it. Don't try to learn something which has to be understood and don't try to understand certain things if they have to be learnt up. Getting it? So don't confuse them and keep on advancing. Okay, keep on growing. So this equation is also balanced now. Now let's move to the third equation, and that's very important. That contains oxalate ion. So it is C2O4 2 minus going to give you CO2. This is it. This is called oxalate ion, C2O4 2 negative. We have to balance this equation. So balance it. Carbon 1 2, this is 2 now. Oxygen 4, 2 into 2, 4 oxygen. Oxygen is also balanced. Carbon balance, oxygen balance, and there is no presence of H ions. So there is no need to add H2O or H ions now. Getting it? Now only charge is supposed to be added. Understand guys, it is not necessary to add H2O or H ions. They are supposed to be added only when oxygen and H ions are not balanced. If they are balanced, there is no need for them. Okay, so we will do the questions based on the merit. If they require that addition of water and H ions, we'll add. Otherwise, we'll put them to the rest. Now charge is remaining 2 negative. So I should add 2 electrons there. So 2 negative there, 2 negative there. This is neutral. Okay, so this is the second equation, and this is an oxidation reaction. The first two were reduction reaction where the electrons were being accepted. Okay, and this being an oxidation reaction, simple as that. Okay, now we'll go to the fourth and a very important equation, very important equation, which is H2O2. If you remember, I told you that H2O2 is a very important ingredient. It is the compound in which oxygen lies in -1 oxidation state, and it is the compound which can go for disproportionation reaction. Oxygen can go to 0 as well as -2 also. Okay, so learn those reactions, keep on revising. If you won't revise, you will always keep on complaining, sir, chemistry is difficult, sir, chemistry is a mystery. It's not. We are not doing our homework. Let's see, there are certain requirements of any subject, of any game, any place. If you satisfy those conditions, you will qualify. If you will not, you will not qualify. Are you getting it or not? So similarly in chemistry, we have to do some homework. Basically, we have to learn certain things. Once we learn that, chemistry can be very scoring. It can be your launch pad for a good rank as well. Okay, but before that, chemistry says, you give me some blood, I'll give you marks. So give chemistry some blood. and it's not red blood. Basically, it wants your sweat. Basically, it wants your hard work, your smart work, and which you are capable of any given day. Okay. So H2O2, a very important ingredient again, H2O2, and they will give you, like say this is going to give you O2. Now balance it. So it is going to oxidize right now, na? Because oxygen is -1 here, it is 0, so -1 to 0 is called oxidation. Now in the acidic medium, oxygen is already balanced, H, 2H, so I will add 2H ions this side, okay? So H also balanced, O to O also balanced. Now charge, this is neutral, 0, and this is +2. So I told you to add electrons to which side? Where we have got axis of positive charge. Axis of positive charge is here only. How much? +2. It is, this side is 0. This is neutral. So how many electrons I should add? 2 electrons. Hai na? So +2 and -2 will become 0. So I should add 2 electrons. And I told you that learn this equation also, if you remember last time. Hai na? So these 4 equations will form the very, very important basic part. Okay, so can I revise? Can we revise these 4 equations? Come on, learn with me. MnO4 negative plus 8H ions plus 5 electrons going to give you Mn2 plus. Remember that, and obviously 4H2O, balanced one. Very good. So 5 electron 8H ions, 5 electron 8H ions. Then we have got Cr2O7, 2 minus 14H plus, and 6 electrons. We are going to get 2 Cr3 plus and 7H2O. Yes or no? So 6 electron, 14H ions. Learn that. And then oxalate ions, C2O4, 2 negative, going to give you 2 CO2 plus 2 electrons. And then we have got H2O2, and it is going to oxidize to O2, 2H plus and 2 electrons. So can you see that? These 2 reactions are the reaction where electrons are donated. These are called oxidation reactions. And in these 2, electrons are being accepted. So these 2 reactions will be called reduction reaction. Getting or not? Learn it because I'll be doing the next few questions with the help of these 4 equations only. And if you have learned them, you will not find any trouble in solving those questions. Okay, so let's begin the question. Now we are going to do redox reaction. These were individually oxidation or reduction reaction. Now if they gave you redox reaction, and what is redox reaction? A reaction in which simultaneously reduction and oxidation occur. Okay, so let me give you a combination of that. So it is like say MnO4 negative and maybe C2O4 2 minus going to give you Mn2 plus and CO2. You have to balance this equation in the acidic medium. Okay, now we all know that here Mn is in what? +7, here +2, yes or no? And +7 to +2 will be called obviously reduction. C2O4 2 negative, you can see that 2x minus 8 is equal to -2, and 2x equal to what? +6. So we are having like say 2x, 2 plus 6, or you can say x is equal to what? +3. And +3, and here we all know x minus 4 will be equal to 0, so x equal to +4. So can we see that x +3 to +4, this will be called oxidation. Increase in oxidation state is called oxidation, decrease in oxidation state is called reduction. Is that clear? So this is the given, so I'll write the equation again. So MnO4 negative plus C2O4 2 minus going to give you Mn2 plus and CO2. So you have to balance this equation. So to balance this, what we'll do, we will first write down the reduction reaction. You can write down oxidation also, it's your choice. So I'm writing reduction reaction, which is MnO4 negative, because I have just learned it. So I'll write down it as casual as possible. 5 electrons giving you Mn2 plus and 4H2O. So this is my first equation. Okay, then we have got oxalate ion, that is oxidation reaction. So for that I'll write down C2O4 2 minus going to give me 2 CO2 plus 2 electrons. Now see how easy my job has become. And don't believe me, you just see the PYQs for the past 15, 16, 17, 18 years. You will see that 70 to 80% questions are combination of the 4 reactions I have written in front of you. Okay, so let's see that. So this is oxidation reaction. Okay, now to balance the redox reaction, this one is reduction, this one is oxidation. Now we have to make sure that in the complete redox reaction, electron should not appear. Electron can appear only in the either reduction reaction or in the oxidation reaction. But in a complete redox reaction, electron should not be present. So our job will be to eliminate the electrons. How we can eliminate the electrons? By cross multiplying by the smallest possible numbers. Okay, so 5 and 2, I believe there is nothing common between these two, so I can multiply this by 2 and this by 5. So this is what will happen. 5 into 2 will become 10 electrons. 5 into 2 will again become 10 electrons. So when I'll add them, the electrons will be cancelled. So let's add them. Let's add them. So simple. The purpose is to delete the electrons in the complete redox reaction. Once you write down separate reduction and oxidation reaction, no problem. Now over here, please cross multiply by the smallest possible numbers so that the electrons become balanced. Okay, so here I have multiplied the first by 2 and second by 5. Okay, so do it. And remember that you have to write down the reactants on the left hand side of the arrow and products on the right hand side of the arrow. So 2 into MnO4 negative, that will be 2 MnO4 negative plus 16H plus 10 electrons plus, now come on, this one 5C2 O4 2 minus, giving you, come on, 2Mn2 plus 2 into 4 8H2O, and what, 5 into 2 10 CO2 and 10 electrons. So finally we can see 10 electrons on the left hand side will be cancelled by 10 electrons on the right hand side, and that was our goal actually, to delete the electrons. Okay, now what is the balanced equation? Remaining thing is your balanced equation. That is your balanced equation. So in this question they can also ask you, in the balanced reaction, what will be the stoichiometric coefficient of H ions? 16. Stoichiometric coefficient of oxalate ion? 5. Stoichiometric coefficient of water? 8. CO2? 10. And likewise. Okay, so one more question, a better question they can ask you is that, look up here. Here we have got 2 moles of permanganate, and we have got how many moles of oxalate? 5 moles of oxalate ion. So 2 moles, sorry, my mistake, 5 mole. So 2 moles of permanganate require 5 moles of oxalate. So they can ask you, 1 mole of oxalate will require how many moles of MnO4 negative to get oxidized? The answer will be 5 requires 2, 1 will require 2 by 5 mole. Yes or no? 2 by 5 mole. These kind of question they can ask you. Is that clear to all of you? Okay, let's do one more question with the same ingredient, but this time with the dichromate ion. Come on, with dichromate ion. So Cr2O7 2 minus and C2O4 2 minus, going to give you Cr3 plus and here CO2. You have to balance this equation in the acidic medium. Come on, so write down the reduction reaction. So I'll write down because I have learned it short while. So it will be 14H plus and 6 electron. Now see that how easier it has become for me to write down this reaction, and trust me, they hold up to 70 to 80% of the question asked in redox reaction. So this will be 2Cr3 plus and 7H2O. So first reaction, that is the reduction reaction. Then oxidation reaction, which I have done previously also, that is oxalate ion C2O4 2 negative, going to give you what? 2 CO2 and 2 electron, the second equation. Now since equations are already balanced, I have to make sure that the electrons are cancelled. The best way is to multiply by the smallest possible numbers. This is 6, this is 2, so I believe that the LCM will be 6 itself. Okay, so can I multiply this by 1 and this by 3? Can I? You can multiply this by 2 also, and this by 6 also, you can, but again they will have 2 common. So in the end you have to cancel 2 from every part of the equation, which is again a tedious task, so we'll avoid it here itself. Okay, so this is 6 electrons, this is 2 electrons. The smallest possible number is what? Multiply this by 1 and this by 3. Okay, Chalo. So, and again, left hand side of the arrow must contain reactants and RHS should contain products. So, see that stuff? Cr2O7, 2 minus plus 14H plus and 6 electrons plus how many? 3. 3 C2O4, 2 minus. On the right hand side, 1, 2 Cr, 3 plus 7 H2O. And this is 6 CO2, 6 CO2 and 6 electrons. 3 into 2, 6 electrons. 6 electrons and 6 electrons cancel. Is there anything which is common? No, nothing else is common. So this is the balanced equation in the acidic medium. Presence of H ion shows that this is the acidic medium. Now again, a question they can ask in the form of numerical is that 1 mole of dichromate ion, 1 mole of dichromate ion requires 3 mole of oxalate. Yes or no? So 1 mole of oxalate will require how many moles of dichromate ion to get oxidized? 1 by 3 mole. I hope that makes some sense as well. So come on, let's do one more question, and that will be MnO4 negative plus H2O2 giving you Mn2 plus and O2. Now, all these ingredients we have seen earlier. I told you to learn the equations of MnO4 negative and H2O2 as well. So we'll write down the reduction reaction. You can write down oxidation as well as per your choice. So MnO4 negative, 8H plus, we have learnt it, 5 electrons giving you Mn2 plus and 4H2O. Now, see how simple it seems now. So, this one H2O2, the oxidation reaction we shall see, H2O2 giving you O2 plus 2H plus and 2 electron. This all we have learned. And that will be the second equation. Now see, our purpose is to delete the number of electrons. So over here we have got 5 electrons and this equation contains 2 electrons. And there is nothing common out there, so I should be cross multiplying this by 2 and this by 5. Okay, so what will happen? 2 into 5, that will be 10 electrons, and 5 into 2 will be 10 electrons. I told you to multiply by the least possible number. Okay, so let's add up now. So that will be 2 MnO4 negative, 16 H plus, 10 electrons, and the second equation 5. So 5 H2O2 giving you, come on, 2 Mn2 plus and 8 H2O. This will be 5 O2. Okay, let me shift it a little bit. That will be fine. 5 O2 and 10 H plus, and yes, 10 electrons as well. So but these 10 electrons will cancel with the 10 electrons, and what else we can cancel? We have got 10 H ions. 10 H ions can be cancelled with the 10 H ions over here. Remaining will be 6 H ions. Anything else? No, nothing else. So that will be 2 MnO4 negative, 6 H plus, 5 H2O2 giving you 2 Mn2 plus, 8 H2O and 5 O2. So that is your equation which is balanced in the acidic medium. Presence of H ions indicate that we are into an acidic medium. So one question they can ask you is that in this equation, what is the stoichiometric coefficient of say H2O2? Answer will be 5. And what is the stoichiometric coefficient of H2O? It will be 8. And similarly 5O2, we have got 6 H ions as well. Acha, even they can ask you numerical also, like what? This equation shows that 2 moles of permanganate will react with 5 moles of H2O2. That means 2 moles will react with 5 moles of H2O2. 1 mole of H2O2 will require how many moles of permanganate ion to get oxidized? So 5 requires 2, 1 will require 2 by 5 mole. Yes or no? So these kind of questions they will be asking you. So be very careful and keep track of the number of electrons, how to balance them. Okay, so let's do one more question. And that is say zinc and reacting with nitrate to give you nitrate ion to give you Zn2 plus and what else? NH4 plus. So we have to balance this equation. So how you will balance that equation? So again, we can see that zinc going to zinc 2 plus is basically an oxidation reaction, and nitrate going to NH4 plus. So nitrate means N is in +5 oxidation state, and here it will be -3. So +5 to -3 means it is a reduction reaction. So this is the oxidation reaction, this one is the reduction reaction. We are into a proper redox reaction. Okay, so let's try to balance it now on the fresh page. Zinc plus nitrate ion giving you Zn2 plus and NH4 plus. Okay, so first write down the oxidation reaction. You can write down any one. So zinc giving you Zn2 plus. So there is nothing else, no O, no H, only zinc is there, and we have to balance the charge. So this is neutral, that contains 2 plus, so I should add 2 electrons, the first equation. Now come to the reduction reaction. Coming to the reduction reaction, we have got nitrate, and this is going to give you NH4 plus as per the equation. Now first balance N is already balanced. Oxygen 3, so I'll add 3 H2O this side. Are you getting that or not? Okay, so now who will tell me how many H ions are supposed to be added? Come on, think of it. Okay, I think that you have got your answer. How many people believe we have to add 6 H ions? 6 H ions. How many believe that? Well, that answer is wrong, because we have to add total number of H ions. We have to take care of total number of H ions on the RHS. So 3 into 2, 6 plus 4 H ions here also, NH4 plus. So 4 and 6 gives you 10 H ions. So I will be adding 10 H ions here to balance it. Getting it? Don't think that only the H ions present in water are supposed to be added. Here ammonium ion has got 4 extra H ions, so we have to take care of them as well. So now the charge -1 and +10 equals to +9. Yes or no? And up there it is only +1. So how can I convert +9 to +1? By adding electrons to the side containing excess positive charge. This is excess positive charge, so I should add, I believe, 8 electrons. So +9 minus 8 will be +1. So I should add 8 electrons this side. Yes or no? So let's rub it off, and I got my equations ready out here. So these are the two equations. Now my job is basically to cancel the electrons. So 2 electrons there, 8 electrons there, and the LCM is also 8. So I believe that I should be able to multiply this equation by 4 and this by 1. That is the smallest possible number I can multiply with. So once that is done, see that 4 into 2, 8 electrons, 1 into 8 will be 8 electrons. So let's write down that thing. So 4Zn plus nitrate plus 10 H ions plus 8 electrons going to give you 4Zn2 plus 4 zinc ions plus 8 electrons and 1 ammonium ion and 3 H2O. That is it. What can be cancelled? Electrons will be gone. Anything else? No, nothing else. So this 4Zn plus nitrate plus 10H plus, the presence of H ions indicate acidic medium, will give you 4Zn2 plus and NH4 plus and 3H2O. Okay, so that is the balanced equation in the acidic medium. They can ask you the stoichiometric coefficient of H ions, also the stoichiometric coefficient of zinc, maybe water also. So you will be prepared with that stuff. Okay, so that is enough practice as far as redox reactions are concerned, and please do practice these questions. And apart from that, other questions which are present in your module or any other sheet you are doing, keep on practicing unknown questions. Very important, because doing unknown questions will actually train you to handle the pressure situation, because in the examination it is a high possibility that you might come across certain questions which you have not seen before or which are a bit twisted. So in that scenario, your ability to handle the unknown will be coming to rescue you. Okay, boys and girls, so keep practicing that, and that is all for the balancing of redox reaction in the acidic medium. In the next lecture, I'll teach you how to balance the reactions in the basic medium. But first of all, do this homework. The 4 reactions I have taught you, that there are basic reactions, learn them by heart and practice them. And as you can see, we have been using all those 4 reactions every then and now. And the chances are very high that they will be there in the modules also. So keep on doing the practice, a hell lot of revision, and I'll see you next time. God bless you all. Bye-bye.